Welcome to Module 9. In this module, for the BEST program, is finished materials and detailing. And what we're going to talk about in this module is just what it sounds like. The materials that go as a finish over top of the SIPs that have now already been installed, and some of the detailing that works in conjunction with those finished materials so that we have a good, durable structure. As is always, we're going to discuss some of the learning objectives that go along with this module, and they include the discussion of the detailing systems about how and what we use to cover the SIP envelope. We're going to discuss a lot about the importance of controlling bulk water management. It's the rain, what comes out of the sky, and where it goes, and how we keep it off of the SIPs and keep it from getting into the house, and some of those details associated with that. We're going to talk a lot about back ventilating. That's back ventilating for both siding as well as roofing, because in certain areas, depending upon where we're building, we have those issues to deal with, as well as the type of siding or the type of roofing requires back ventilation. And in addition, we're going to talk about when we fasten those finished materials to the SIP wall or the SIP roof, we also want to be aware that how we attach it is firmly attached. It's going to stay there forever and it's properly dealt with. So getting started in the discussion about bulk water, we're going to use this diagram, which very clearly shows that water that comes out of the sky, we want it to drain down and away from the system. This detail comes to us from the Building Science Corporation, the same folks that wrote the book that SIPA promotes, which is the Builder's Guide to Building with Structural Insulated Panel. And in this diagram, you can see that anything that falls out of the sky, whatever it hits, whether that be the roof or the siding, we want to drain it down and away. And that's important always to remember. When we attach siding to the SIP envelope, we want to think about, or roofing for that matter, we want to think about a couple of different things. First of all, when we fasten it, we want it to hold firmly, yet we also want it to move with the structure, because all structures move, whether it be the ground shakes or the wind blows or the structure settles a little bit. That fastening has to be durable and has to stay with it, but allow some type of a movement. In addition, we want to detail it so that we accommodate the environment. And this is where we have to interject the point about you as a builder are building in a certain geographic climate, and what works for one builder may not work for the other builder. Those building in Florida don't detail the same as those building in Phoenix or those in Seattle. They deal with different amounts of rain, different environmental conditions, and everybody has details that are specific to those general environmental conditions, and you have to make sure that you appreciate that. As always, because we know that siding leaks and other finished materials often leak, we have the desire to make sure that we have the way for water to drain and dry, or the materials to drain and dry. It's just as important as trying to keep it out. It's important to know that when it gets in, and it will get in, that you give it a way to get out and a way to dry out. So with those things in mind, we want to start talking about, well, what do we put on the outside of our SIP envelope? We're going to start talking about walls. So with walls, we deal with siding. And when asked the question, well, what can I attach to this SIP envelope? What kind of siding can I use, or which kind of siding can I use? I'm going to respond that whatever you can design and attach to a conventionally framed structure, you can design and attach to a SIP envelope. There's no restrictions in that regard. Different types of siding, again, have different fastening techniques and different forms of ventilation and things of that nature, but whatever you can put on a stick house, you can certainly put on a SIP house. The photos that you see now behind me, when we talk about siding choices, it needs to be determined whether or not that back ventilation is required. And that's a crucial element that we're going to hit time and time again. On the left, you can see that the detailing uses the felt paper as a drainage plane, and then we've got the offset furring strips, which in this case are a metal furring strip, which provide a huge amount of airflow behind that cedar lap siding. And that gives the ultimate look on the outside, no different than if it had been attached directly to the SIP, but because of the ventilation strategy, which allows air movement behind that siding, it keeps it dry and allows it to be a durable member on the outside. This detail is showing how we might attach as well as accommodate the ventilation or the ventilating of cedar shingles or a stucco or a manufactured stone veneer wall. Now, this material is all referred to as reservoir cladding. Now, reservoir cladding is exactly what it sounds like. A reservoir holds water, and a cladding that holds water is a reservoir cladding. This material can absorb water, hold on to that water, and just at the time we don't want it to, it's going to push into our living environment or into our SIP and cause problems. We don't want that to happen. So there's two things that we can do. We can either seal the back of the reservoir cladding to prevent the moisture from migrating or moving through, or we can separate and give a path for that moisture that does get through to drain down and away. So there's two ways we can look at it. In this diagram, we're showing any one of these siding materials with being offset by metal lath and allow a space for the drainage to occur with the material that does allow water to pass through to drain down and away through that ventilation area. If we're dealing with a wood or a fiber cement clad wall, we have the same issues. There's still a reservoir cladding. And again, we can seal or separate. With the wood cladding, you can seal the backside of the wood to prevent that moisture from moving through, or you can separate it with back ventilation. Keep in mind, back ventilation isn't just an airspace, it's also a way for air to come in the bottom and out the top, because that natural circulation is going to develop from heat rising behind your siding, and we have to give a way for a bug-free shielded cavity vent to allow the air to move into that ventilated space where moisture can drain out and down and away, and then that heated or that air that's taking the moisture with it go to the top of our wall cavity and vent back out. So it's a fairly simple, yet in some cases hard to understand concept to provide this air movement behind your siding. In this detail, we can see how wood cladding or that lap siding, a very simple siding system, is being separated from the drainage plane by the use of what's really a simple idea of using a foam strip, or in this case, strips of fan fold. And fan fold material, which is often used in residing, in this case is ripped down to 3 to 4 inches wide, and it provides a strip that allows for some ventilated space between the wood and the drainage plane. Just a good way to allow that ventilation to get in behind. In this photo, you see a larger picture of how we are detailing around the window, how the ventilation strips vertically behind the siding allow that ventilation space to get behind it. Now the next one we're going to talk about in this detail is vinyl or aluminum clad walls. Now vinyl and aluminum clad walls might be construed as a budget-oriented item where we can't afford perhaps a more elaborate siding system, but one of the huge benefits of is they're both self-ventilating. And when I say self-ventilating is, although they leak like crazy and a lot of water can get behind them, they also leak enough that they also allow air movement through the system. A vinyl siding system has enough weep holes and enough places for air to move in and around that it self-ventilates and removes the moisture that ultimately leaks through it. So that's a great thing. If your budget only requires that type or allows that type of a siding to be incorporated, you may consider yourself lucky that you've got a self-ventilated siding that you're actually using. Now with all these sidings that we may install or apply over the SIP envelope, one of the things that we always want to ask ourselves is how do we fasten these sidings? And some builders have come to me and said, well, I want to put this type of siding, how do I fasten it? What's the fastening schedule? And the correct response is really it's all a function of what the siding manufacturer specifies as the correct fastening schedule. It's really not up to the SIP manufacturer. It's really not up to you as the builder to determine what that fastening schedule is. It's up to the supplier or the manufacturer of the siding to know what it's being attached to and recommend that the fastening schedule is appropriate for attaching into 7/16 inch OSB, if in fact that's what the skin on your SIP is. If it's something else, the pull-out value of the fastener specified has to be a known entity to the supplier of that siding so that they can calculate what the difference is. If you were to look at general rules of thumb, it's often considered that the decrease in pull-out value, because we don't have studs in our system, mean that an increase in number of fasteners of about 20% equates to an equivalent overall fastening or holding power of whatever those fasteners are holding the siding onto that SIP skin. So a 20% increase in your fastening schedule is commonly seen throughout the industry. In these walls, after we've attached siding, we also have to worry about probably the number one problem with not only energy problems, but in a lot of cases moisture problems, is window and door installation. And this is where you as a builder really need to step up your game when dealing with super insulation and energy efficient housing. Not only do we need a good door and window of good quality and good ability to hold out air, but it's got to be properly installed. It's really no different than the SIP system itself. A SIP is a great product, but poorly installed, it doesn't work properly. A window and door is exactly the same way. It has to be installed properly. I've heard some people say there's two types of windows, those that leak and those that will leak, which means windows leak, just like siding, they leak. So the installation detailing of the window and the doors needs to address the fact that occasionally or eventually water is going to get into that enclosure, and you want a system that allows that water to drain down and away. Just like the very first detail that I showed you, bulk water needs to drain down and away. And if you're siding, you're flashing, you're caulking, or your system starts to fail and water gets in, you need a backup plan of damming and allowing that water to get out. Now this screenshot that you're seeing is a portion of many installation guidelines about how to properly install and detail window flashing. This could be an entire module in and of itself, but we're not going to do that to you. We're going to ask you to go to the guide for installing SIPs and look at what Building Science Corporation has very clearly shown as proper techniques to provide things like pan flashing, to provide a sloped sill to promote water drainage, the proper way to incorporate house wrap around door and window installation so that we've always got a shingling situation and water can never get trapped behind your windows and doors. Time spent in that book and understanding these proper installation methods are crucial. They're crucial for you as a builder to know that when you put windows and doors in your structures that they eventually may leak, and you want to know that you've got the proper flashing details so that that water can be controlled and always drain down and away. Well, now that we've talked about the exterior siding finishes, let's move to the inside of the house and talk just a minute about the interior finishes. Again, we want to know what and how we're going to cover up the inside of the structural insulated panel. There are some manufacturers that have taken the position that because we're building the SIPs in the factory, we might as well take the extra step to apply a pre-applied interior finish. Now that pre-applied interior finish could be gypsum, it could be a tongue and groove wood material, it could really be anything that could be added to the SIP, then when shipped to the job site and stood up, your interior finish is already applied. We found that there might be some issues with some of those pre-applied finishes when proper consideration isn't taken into things like weather, site conditions, installation requirements that may mar, damage, or cause problems with those interior finishes. And if you've paid for them once and you got to go back and fix them a second time, then you're paying twice, and it may not be the right thing to do. And again, it's dependent upon your location, your design, what the capabilities of the panel provider are, what type of material you're talking about, and how durable it is, and how skilled you are as a panel installer to make sure it doesn't get messed up. You also need to take into consideration if you're in an area where the interior of your SIP joint needs to be sealed with either a SIP tape or some type of vapor barrier that prevents any moisture or air movement through that joint. If you have a pre-applied finish, that's going to make that awfully difficult. So the pre-applied finishes in some cases will restrict your ability to properly seal your panels. From a building science perspective, this means that although theoretically it sounds like a good idea to pre-apply finishes, from a building science point of view, you need to look at it and see, are you compromising the sealing of your system and perhaps causing a problem further down the road that you don't want to deal with. So in addition to sealing the underside of the panels, the other thing that needs to be considered by you, the installer, when talking about finished materials is movement. Because if you have pre-applied material and things start to move around, you may get cracks or problems with your finish that you're not ready or you're not prepared for. A perfect case is this when you think about working with timber frames or rough sawn lumber, or in some cases roof support beams that are green timber. Well, green timber shrinks. And when green timber shrinks, bad things start to happen because finishes all of a sudden can expose cracks. one of the things we do in a lot of cases over timbers, beams, or support components for roof is we apply a furring strip. And what that furring strip does is it separates the roof panel from the beam or the support element, and it allows the siding, or not siding, the interior finish, whether that be gypsum or T&G, to slide behind the beam so that the end of the material is hidden between the beam and the SIP itself. And then if that beam starts to shrink, we don't have those ugly cracks that we don't want to see as a result of timber shrinking. The photo on your left clearly shows what at one point in time was drywall and trim and everything that butted very neatly to a piece of timber post. And over time, that green timber, as it shrunk, created a very large gap. That's a finished detail that's going to require a lot of effort to come in and correct. However, if the material all slipped behind the timber and as the timber shrank, about the most that you might have to do is go back in and repaint that material. Now the picture on the right clearly depicts some of the problems that I referred to earlier when we talk about pre-applied materials. If we pre-apply finish to a structural insulated panel, ship it to the job site, and we're not prepared for it, bad weather conditions, improperly trained installers, or design issues may end up with a pre-applied finish that looks like what you see here. That's a water-stained drywall that has got obvious moisture issues. In some cases, the drywall may have footprints over the top of it. And when your drywall finisher shows up to deal with issues like this, they're not going to be real happy, and it may be a problem. The alternative to pre-applying that site finish may actually be, while you're installing your panels, is to do some site-applied interior finishes. This can be done with either a gypsum being applied or as well as a T&G. In both cases here, we're dealing with a timber frame issues, but it doesn't have to be a timber frame project. It can be merely a project where you're installing materials behind beams or behind elements, structural support elements, that it makes sense to pre-apply these finishes or to a site apply these finishes as the panels go up. The other thing that I want to mention is when you're dealing with finish systems or detailings, one of the things that we really don't like to see is penetrating the envelope. And I bring this up because I want to talk about false rafter tails or rafter tail details that are sometimes required based on the architectural aesthetics of the project. If you've got a bungalow style house and it's got all these rafter tails, there's a right way and a wrong way to incorporate these rafter tails. This picture actually shows a ridge beam, not a rafter tail, but it shows it clearly penetrating the envelope, meaning it's penetrating the wall. And when you have a beam or a structural element that penetrates through your insulated envelope, and then something moves or shrinks because it loses moisture, or if it's wood and it cracks or checks, you now have the potential for air and moisture to move through your insulating envelope. You're much better to put something on the outside that is described as a false tail or a false rafter tail, fake. In this picture, we're clearly showing a whole bunch of what looks like rafter tails, but in essence, they're short pieces of wood that were attached to the underside of the overhang to give the illusion that we have a real rafter tail that penetrates through the envelope. This is a detail that's critical from not only an energy efficiency, but from a building science perspective, that we don't want air and moisture moving through our envelope. So let's all agree, if we can avoid it, we don't want to penetrate the envelope with anything, because it just creates a thermal bridge and a potential for problems. If we want to add rafter tails or some type of a fake tail on the edge of our panel, and we want to provide that extension, we have the ability to do that on panels, and this series of photos clearly shows that we can create a rafter tail with whatever profile we want, put it into a thicker roof panel. It can be slid into a recessed pocket or groove created in the foam, and in essence what you get is you get a rafter tail that's really only the last couple of feet of a panel. There's engineering aspects that go along with this because obviously we have limitations as to how far that tail can stick out. We have to attach it properly, it has to be designed properly, and you need to make sure that you're consulting your panel designer as well as the engineering review to make sure that you're not violating good common sense in that regard. Next, let's talk about roofing. We've finished everything in terms of walls and siding and windows and doors and things of that nature. Let's move to the roof. What kind of roofing can we attach to a SIP? any kind that you can attach to a conventionally framed structure, you can also attach to a SIP structure. There's no restrictions. Whether it be regular composite asphalt shingles all the way up to slate and concrete tiles, any of them will work, and they work just fine. We have to ask ourselves the exact same questions. And those questions, first and foremost, are going to be fastening. What's our fastening schedule? In the same fashion that we looked at the fastening schedule of siding, we also look at it in roofing. This is most particular in metal roofing, because metal roofing uses cleats or clips that are screwed through and attached to the sheathing. In this case, we don't have a rafter to attach to, so that decrease in pull-out value of the fastener will often dictate an increase in the fastening schedule by about 20%. That's a determination that the siding provider, the roofing provider should make. Just as in the siding, they dictate what the fastening schedule is, so does the roofing provider. And those are the things that we need to do. In addition to the fastening schedule, the other thing that we always ask ourselves when applying a finished material is back ventilating. What type of ventilation system is required? Let's talk for a second about ventilating the roof system. Now, let's not confuse ventilation of a roofing system with ventilation of an attic. An unconditioned attic in a conventionally framed house is ventilated by virtue of the fact that we bring in fresh air and we let it exhaust out of either gable vents or ceiling or circular fans or whatever is required to get air movement through that attic. Well, we don't have an attic. We have conditioned space under our roof, and when we talk about ventilation, we're talking about back ventilating the roofing material just as we are back ventilating the siding. Everything is on the outside of the panels, not ventilation on the underside of the panels as is a conditional attic space. Now, when do we need to ventilate this attic? Well, and why do we need to ventilate this attic? The building scientists tell it we need to ventilate it when we have a threat of excessive moisture and the moisture cannot dry out. Where do we have these situations? Depends where you're building. If you're building in Seattle, if you're building in the cold, wet northern climates where we don't have a capacity to dry, then whatever type of roofing system we want to attach, there ought to be some ventilation associated with that. Some people are under the misperception that ventilating your roof system really is a function of shingle heat and shingle warranties. And that's really not entirely true. If we look at the testing and the research that's been done with shingle warranties, we find that what causes shingles to prematurely deteriorate is in fact heat, but what are the areas that cause heat to build up? First and foremost, it's geographically where we build. Secondly, it's the color of the shingle. And thirdly, it's the orientation of that roof pitch. Is it the south side or the north side? Way down on the list, and that which only really increases the temperature of your shingle by a couple of degrees, upwards of maybe 5 to 7 degrees Fahrenheit, is going to be whether or not that shingle is back ventilated. Okay? If that shingle only is going to increase a few degrees, it may see a marginal decrease in its overall life. Whether or not it should adequately determine whether or not the manufacturer should remove a warranty is between the manufacturer and, I suppose, their lawyers. What we really want to know here is whether or not it's necessary to back ventilate just because of a shingle warranty, or should maybe we look at a different type of a shingle or roof covering that is easier to back ventilate. We can back ventilate asphalt shingles. We can use a number of ventilated mats or furring systems, or lay entire second decks over top of the SIP system to give it the ventilation and know that we don't have any of those concerns. What I'd really like you to understand is ventilating your roof system has more to do with drying than it does with heat. So when people refer to a cold roof versus a hot roof, what I'd like you to think in the back of your mind is, what we're really talking about is a wet roof versus a dry roof. Depending upon the climate you're building in, you may actually need to ventilate that roof to remove moisture, much more so than we're talking about ventilating to removing heat. In this photo that you're seeing right here, you can very clearly see some of the thermal bridging of the screws coming through the panels. You can clearly see that we've got a nice layer of snow over top of this roof. We don't see huge areas of heat escaping from the inside, so therefore we don't have huge concerns that we've got a problem in this actual roof. One of the things that you might notice is that the snow thickness on the overhang of the gable end is actually a little bit heavier than it is over the field of the roof. And that's interesting to note because it proves that the R value of the panel, even though it's very high, some small amounts of heat are going to get through that system and cause that snow to melt at a certain pace. This is why when we back up and we think about roofing systems, we still want to consider ourselves, we need to consider the potential for ice damming, and why we still want to use things like an ice and water shield along the eaves of our buildings as well as into the valleys. After we talk about roof ventilation, the next thing that we might want to discuss is shingle ridging. You may have heard of this issue. Shingle ridging is really a function of movement, and it's movement as it relates to heat and moisture. When heat and moisture can get into a system, a roof system, the expansion and contractions that is associated with that moisture or that heat may cause a slight amount of movement in your roof system, which can cause buckling in your shingles. If we really want to get away from shingle ridging, we need to disassociate the roofing from that SIP, which means a nice ventilated space or another layer of decking will do that for us. It might be interesting to note that if we took a lesson from our European neighbors, we would notice that they don't use a whole lot of asphalt shingles. And what they do use is a whole lot of tile and slate, and they use roofing systems that are all self-ventilating. Just like we talked about the self-ventilating properties of a vinyl or an aluminum clad siding, the roofing opportunities also exist for you to use a material that is self-ventilating. So if you start dealing with a system like some of the crimped metal roofing, some of the slate or the tiles, you have not only a durable product, but one that is not susceptible to shingle ridging issues and is also self-ventilating. And that's a wonderful thing. The shingle industry reports that shingle ridging really is not a huge problem. In fact, it doesn't happen anymore with SIP panels than it has with conventional framing. It's an issue that's predominantly an aesthetic issue. In most cases, when shingle ridging occurs, it's a function of the sun being at the right height and you see a slight shadow line. In most cases, the shingle ridging will disappear over time as the shingle relaxes and lays back down flat. It's not necessarily an indication that you've got a failed system, that you've got an energy leak in your roof. It's merely an aesthetic issue, and it's one that you shouldn't spend a great deal of time concerning yourself or cause you not to use shingles. If you decide not to use shingles and upgrade, you may take a lesson from the folks in Europe who opt not to use asphalt shingles, but to step up their game with a self-ventilating system, which is either going to be a tile or a slate system. Now, these systems, although they come with a price, they really are a great system in that they self-ventilate. Just like the aluminum or the vinyl siding self-ventilates, such that it can dry out. If you go to an upgraded roofing system like a crimped metal or a tile or a slate, you've got a system that is inherently self-ventilating and will solve some of the issues. And of course, you're never going to have any of the problems with shingle ridging that might be associated with some other types of roofing methods. Ultimately, the best finished detail that you'll ever put in your SIP structure is going to be a blower door test that proves that what you've done throughout is a good tight envelope. So remember, you can't build it too tight, you can only not ventilate it right. And at last, before we close this module out, I want to remind you once again that a lot of the details that were used in this module came directly from the book, which is The Builder's Guide to Building with SIPs. It's going to be an important part of your education and understanding how to properly detail and work with SIPs, most importantly from the building science perspectives and the things that we've talked about in this module. We'll see you at the last module here in just a little bit.